సో దీన్ని ఇప్పుడు ప్రస్తుతానికి
Good morning, everyone.
Good morning.
So today we will be covering the project 2 and the only topic which is left. Okay. Do you have any questions before I start with today's session? Even though I have given enough time yesterday, I haven't received assignments yet. I'm not sure what is happening. So if it is in the middle of something, then I can understand. Okay. Anyways, so I'll share my screen. Just give me a moment. Okay. Sorry, I'm on mute. Um, So today's topic is ELB, elastic load balancer, and auto scaling group, ASG. Let's assume I have a server which has an application running. But ideally, we will not have one server for the application. For high availability, we will have multiple servers. Okay, let's assume I have 3 servers serving the application to the users, like a Facebook or any other application. Okay, now if I have 3 servers having the same application, these 3 servers should be utilized completely. Let's assume this each instance of table of 100 users. Okay, now if there are 300 users, these users should be able to access the servers equally. One should not be overutilized, one should not get 200 requests, one should not get only 10 requests. It should be equally distributed. In order to do that, in AWS, we have an elastic load balancer. So this elastic load balancer will distribute the traffic to the instances which are in the target group. The load balancer, whatever the request coming from the internet, it distributes to the instances or targets. This is basically called as target. in the target group. Okay. So the load balancer will balance the load by distributing the traffic to the EC2 instances which are in the target group or targets in the target group. That's one of the functionality of load balancer, basic functionality. The other functionality is load balancer will check the health of the EC2 instances before it sends request to it. Okay, for some reason, if this EC2 instance is unhealthy, load balancer will not send traffic to that instance. So load balancer will direct the request only to the healthy endpoints. So what are the two functionalities? It will distribute the traffic equally to all the targets in the target group, balancing the load. And the second functionality is checking the health of it. Okay. Now, let's assume the load balancer is having 3 instances and there are 300 users. But all of a sudden, there is an increase in the 200 users. Okay. Now what will happen? Load balancer, as usually, whatever the request coming from the internet, it will distribute to the EC2 instances without knowing whether the instances will be able to handle it or not. So if you remember the functionalities of load balancer, it will whatever the request coming from the internet, its responsibility is to distribute traffic to the targets. Okay. But the load balancer will not know whether the instance will be able to handle it or not. Now, in our scenario, each instance is capable of 100 users. Now, there are 300 users who are accessing it initially. Now, there are 200 more users who is accessing the application all of a sudden. Okay. Now, if they try to access the application, what will happen? The first thing which happens is the CPU rises. The CPU rises. So it will go to 18, 19, 95. And at some point of time, it cannot handle and this becomes unhealthy. Now, load balancer will not send traffic to that instance. Eventually, even this instance, CPU utilization will cross 90%. It becomes unhealthy, and even this. So load balancer will end up sending traffic to no EC2 instances. Okay, and the users who is accessing will face the page not found error. To avoid this kind of situation, what we can do is we can go for auto scaling group. So we need to add this target group under the auto scaling group. Okay, we need to add this target group under the auto scaling group, defining the policies in such a way that if the average CPU utilization of all the EC2 instances in the target group is greater than or equal to 80%. This number can be flexible, okay? 60, 70, 30, 40, it's completely up to us. Ideally, if we cross 80%, yeah, this is something which we need to take care. Okay? So if the average CPU utilization is greater than or equal to 80%, you can allow the auto scaling group to add an instance. because the target group is under the auto scaling group, the auto scaling group will add an instance in the target group. Now, as soon as an instance is added, load balancer will start sending traffic to that instance after checking the health of it. Even after adding an instance, if the CPU is still touching 80%, auto scaling group will add one more instance. And again, auto scaling group will start sending traffic to that instance as well. Okay. So auto scaling group, based on the CPU utilization, it will keep on adding the EC2 instances, making sure that the users will be able to access the request based, even in demand. Okay. Now let's assume there is already an application, right? There is a new version of the application is being implemented. Basically, there are few features which are added to the application. Okay. And they made it live. The application was made live without testing properly, where a piece of code in that new feature is going to an infinite loop. Excuse me. Is going to an infinite loop. Now, what does it mean when I say a piece of code is going to infinite loop? Means a set of lines is executing infinite number of times, continuously, unlimited times. Okay. Now, usually, if the loop doesn't exit, the first thing which happens is CPU rise, because it is executing again and again, taking a lot of compute power. Okay. Now, because the new feature has been implemented in all the EC2 instances, because of this infinite loop, all the instances CPU utilization will just rise. And within no time, it will touch 80%, and auto scaling group will add an instance. Even that instance is having a new application that also goes for infinite loop, and again, the CPU will touch 80% and auto scaling group will add one more, and then one more. In simple terms, the auto scaling group will go crazy, adding the EC2 instances. Now, in this particular scenario, the auto scaling group is adding the instances not because there is an increase in the number of users, right? Because there is a manual bug in the code. Correct. Now we want to add the instances when there is an increase in the number of users. But there are scenarios where it would rise, not just because of the number of users. So in this, to avoid this kind of situation, what you need to do is you need to define capacity for the auto scaling loop. So for example, you can say maximum number of EC2 instances can auto scaling group add is 5. Now, if you keep 5, auto scaling group, based on the CPU utilization, auto scaling group will add the instances, but will never go beyond max. Now, how can you come with the conclusion that, okay, I need maximum of 5? So depending upon the number of users you have and the number of servers you have. So this has to be investigated, or it has to be monitored initially to come to a particular number. So if you know that, okay, we have 500 users, now we have a server is capable of 100 users, now we need 5 servers max, not more than that. So in worst scenarios, you can keep it as 6, but not 10 or 15. Okay. Now, based on the policies, it will scale, but it will never go beyond the maximum capacity. Okay. Now, let's understand the other scenario. Now, assume the number of users are actually reducing, whatsoever the reason. Now, auto scaling group not only add the instances based on the CPU, we can also reduce it. Okay. Now, maybe if the CPU is less than some 60 or so, I wanted to remove the instances or 30 or 40. So auto scaling group will start removing the EC2 instances when the number of users are actually reducing. Okay. Now let's assume for an instance, there are, when in a situation, there is only one user who is accessing an application. Only one user. Let's assume. Now, if an instance is capable of 100 users, now if there is only one user accessing it, the CPU of this EC2 instance will be still less, isn't it? Definitely it will not be 60 or 80. There is only one user who is accessing the application. Now, auto scaling group, based on the CPU, it may terminate this instance also, where this user is facing the downtime while accessing the application. Okay, that means this application is not highly available. For example, if you open a Facebook around 2 or 3 a.m. in the morning, will it ask you to come back at 8 or 9? No, right? It will be still open. That means the Facebook application is highly available. Okay. Now, to avoid this kind of situation, see, based on the CPU, you want to terminate it. But maybe if you have few users, you want to keep at least one instance or so. Okay. Then what you can do is you can define a minimum capacity. For example, in our scenario, I can keep it as 1. I can keep it as 1. Now, if you keep the minimum as 1, even if the CPU utilization of an EC2 instance is less than the 10% also, doesn't matter. Auto scaling group will make sure it has minimum number of instances running all the time. All the time. Okay. So see, auto scaling group is basically you're automating the scaling of the EC2 instances or basically the targets. Scale in or scale out. Okay. Now, if you are automating, you should be knowing a way where you can control the auto scaling group. That can be done using the capacity. Okay. Now, yes, I'm saying that auto scaling group will add and terminate the instances. Will add the instances based on the demand when the number of users are increasing and terminate it when the CPU is less. Terminating is fine. Now, when auto scaling group is adding an instance, how auto scaling group know a particular kind of instance to be added with the kind of configuration, or how auto scaling group know that kind of application has to be added with the help of a launch template. Okay, as the name suggests, a template, launch template is basically a template which you would be providing to the auto scaling group, like the T2 micro. This is the AMI which has the application. So you have to define the configuration details of the EC2 instance in the launch template. And using the launch template, you can create an auto scaling group. So without a launch template, auto scaling group doesn't exist because whenever a policy kicks in, auto scaling group should know what kind of instance to be added. So that it will follow this template. And you can create multiple versions of this template, of the same template basically. So when you create a template, by default, you will be having a version 1. And if you want to create another template, with a few different configurations. So as simple example could be, I want to have a template of my T2 micro, and later I realized that I want to go for T3 nano. You can create another version of the same template, and you can select that version for the auto scaling group by editing the options. And after the template has been changed, whenever autoscaling group needs to add an instance, it will follow the new configuration. But the old instance will be untouched, will remain same. Okay. So having a load balance and auto scaling group, we can actually make our application highly available and fault tolerant. So highly available is basically making sure the application is available all the time. And fault tolerance is even if there is a fault, it is tolerant enough. So if you take auto scaling group, it can heal itself basically. Okay. Now let's assume if an EC2 instance is unhealthy, all of a sudden it becomes unhealthy. What load balancer will do? It will just stop sending traffic to that instance until and unless it becomes healthy. Okay. It will stop sending traffic to the unhealthy instance. But you know what autoscaling group will do? It will just go and replaces with a new EC2 instance. So if there is a fault, it can handle itself, it can heal itself by replacing with a new one. Okay. So any questions, please? Folks, you're following me.
So Anupama, ASG can be applied only on a target group or how it is?
Need not be on target group all the time. It can be simply there. What if you don't have a load balancer?
Correct.
Yeah. So load balance and auto scaling group is basically a great combination, in fact.
And what services we can include in ASG apart from EC2
Containers.
containers?
So let's say implement this in the console then. Just give a moment. I will log in and share my screen. Sorry, I'm just giving a moment, please. So now what we're gonna do, yeah. First of all, we will launch an EC2 instance. Basically a manual instance. We will make sure that it has a web server so that we can access using the public IP address. Okay, we are accessing this instance now using public IP address initially. And then we will create a load balancer with the target group, and we will add this instance as a target in the target group. As soon as an instance is added, load balancer will start sending traffic to that instance. Yeah, after checking the health of it. Okay. So then we will create a launch template. From there, we will create an auto scaling group from that, defining the policies and capacity. So for the demonstration, what we will do, we will define the capacity. Minimum capacity, I'll keep it as 2, max as 5. You also have another value which is desired, like the desired number of instances you want to start with. So I'll keep min and desired as 2. Now to maintain the minimum number of instances, auto scaling group immediately adds 2 instances into the target group. And load balancer will start sending traffic to that instance after checking the health of the instances. Okay, so I would repeat. So first of all, we will launch an EC2 instance. First step is launching an EC2 instance, having a web server in it so that you can access using the public IP address. Okay. Now the second step is creating a load balancer and the target group, and we will add this target into the target group. So this is a manual instance which we are adding, which are creating or launching manually. Okay. Now, as soon as an instance is been added, load balancer will start sending traffic to that instance. Now, this instance is no more accessible using public IP address. We access using load balancer. So load balancer usually will have a DNS name. We access the load balancer using the DNS name in order to reach the instance. Okay. So second step is creating a load balancer, launch and target group. Both are integrated. Okay. And we will add the instance into the target group. The third step is creating a launch template. We'll create a launch template and we'll create an auto scaling group from the template, defining the policies and capacity. So to maintain the minimum number of instances, auto scaling will immediately adds 2 instances without considering the manual one. Okay. Now the fourth and the last step is, if you access the load balancer DNS name from your browser, the load balancer should be able to distribute the traffic to all the 3 EC2 instances, one by one. Clear what we're gonna do? Yes. Folks, please respond.
Yes.
Yes.
Cool. So first step is launching an EC2 instance. Let's do that. We will be doing little different. Okay, this time.
But Anupama, just speak slow, this time.
Anjali, you do with me, Emma?
Yeah, no, not at all. I'm not.
Okay, sure. I'll be slow. So first step is launching an EC2 instance. So go to instances, click on launch instance. So I'm naming it as manual instance because we are manually creating this instance. Now for the AMI, I would choose Amazon Linux 2 AMI, which is under free tier. Okay. So AMI, we are choosing Amazon Linux 2. So usually we will choose Ubuntu only, but for this demonstration, we are using Amazon Linux 2. There is a reason for that. Instance type, as usually, we'll go for T2 micro. For key pair, I don't need a key pair, so I'll proceed without a key pair. I would use the default VPC only. I'll keep with the default VPC settings. And for the security group, if I am not having a key pair, that means I need not connect to the instance. I'm not connecting to the instance. If I'm not connecting, do I need SSH protocol? No. But I want to access the EC2 instance using the public IP address. That means, of course, I access web server using the public IP address from the browser. So I need to open the browser protocol, which is HTTP. Okay, I'll stick with the root volume. Now in the advanced details, there are a few things which we need to do. First thing is the user data. Okay. So user data is basically an automation. If you want to automate the installation of few softwares or update or upgrade your operating system, you can use user data. It's like a bootstrap script. So if it is a Linux, we use bash scripts. If it is a Windows, if I have chosen a Windows AMI, I would go for PowerShell scripts. Okay. Now in this particular scenario, I am basically writing a script to install a simple web server, okay, and access it from the browser. So it's saying it's a bash script. Now I'm updating it. See, if I am using Ubuntu, I would say apt-get. But if I am using Amazon Linux or even Red Hat, I'll go for yum. So these are the package management tool. So sudo apt-get update, sudo yum update. So the installation of packages, updates or upgrades happen using a package management tool. So this package management tool will change based on the AMI you choose or based on the operating system. So because we have chosen Amazon Linux this time, we'll go for yum. So yum update, yum install HTTPD. So in Ubuntu, the basic web server name is Apache. In Amazon Linux, the basic web server name is HTTPD. Ultimately, it's a web server only, just naming convention. Naming is different. Okay. Now I'm installing HTTPD. I'm starting that service. I'm starting service HTTPD start. And I'm making sure that this service is on even after rebooting my instance. This command, what it will do, even if I reboot my instance, sometimes accidentally, or if AWS reboots an instance, I need to make sure this service is on. Okay. Now I'm taking a public IP address of the EC2 instance by running this command and assigning to the variable called IP_addr. Okay, so I'm defining a variable and I'm storing the public IP address of the instance. Now, where I can get the public IP address, I'll get it in the metadata folder, and this metadata folder will be there in the latest folder. Okay, now I can find this latest folder when I run this generic command. So 169.254.169.254, this is basically a generic IP address which we can run on a server to get the metadata of that particular server. Okay, so the EC2 instances are no different. They are also virtual machines. It's like a server. So we are running this command to get the public IP address assigned to this variable. And I'm using this variable in the home page, like in index.html. I'm saying echo manual instance with IP, and I'm defining this variable here. And I'm displaying this information in the home page, index.html. Now, when I take the public IP address and keep it in the browser, it will no more give me a default page. Instead, it will give this message. It will give this as an output. Man instance with IP. In this, because it's an environmental variable, in this place, I will get the public IP address of the instance. Okay. And I'm creating another page called health.html, which is saying, okay, so what you can keep whatever you want it in the quotations. I'm just keeping it as okay. Okay. Now, why I'm creating the health.html? I'm creating for the load balancer. So I said the load balancer will check the health of the EC2 instances, but how does it check? Okay. So what we need to do is for the ELB, we have to provide a path. So I'm providing health.html as a path or a page name. Now, whenever load balancer need to check the health, it will hit this path. Now, obviously, when if instance is healthy, it will respond. So load balancer will mark this as healthy at that time. If it is not responding, that means unhealthy. Okay. So it's a bash script. I'm updating, I'm installing that HTTPD web server. I'm starting that service and I'm making sure that the service is on even after reboot. I'm taking a public IP address of the instance, assigning to a variable. And I am displaying this message, man instance with IP, which is having IP address in this page, in the home page. And I'm creating another file called health.html for the load balancer. Okay. I repeat, you can keep whatever you want it in the quotations. You can just simply say healthy or kind of whatever. Okay. So that's the first thing which you need to understand. Second thing is, in order to access the metadata, first of all, you have to enable it. If it is already enabled, how we can access it? Go for V1 and V2. Because token is something which is asking, we don't have it. So go for V1 and V2. Okay. And enable the tags in metadata. So there are two different things which are new for this hands-on when it comes to EC2 is metadata has to be enabled. Okay, if you disable it, the metadata, basically the public IP address from the metadata folder cannot be accessible. Okay, so we have to enable it. And very importantly, the metadata version has to be V1 and V2 token optional, not V2. Because if we go for V2, token is required. We don't have any token as such. So V1 and V2. And I think this is optional, but keep it as enabled just in case. Okay, and then launch an instance. Now that the instance is ready, been launched, I mean to say. Now it's in pending state. So once it is in running state, we can take the public IP address of the instance and access the web server. Okay. Now the second step is going to the load balancer, creating a load balancer, target group, and adding this target into the target group. Okay. So first of all, this instance is running now. So I can simply take the public IP address and access from the browser. Ideally, it should work. Okay, let's see. You see? So it's saying manual instance with IP, the IP address, the public IP address. Because I have enabled the metadata accessible and V1 and V2, I am able to see the public IP address. But if you miss that option, folks, you will not see the public IP address. You would say manual instance with IP and it will be simply empty. Okay, make sure you enable those options when you are doing the hands-on. Okay, now let's move to the next step. So create a load balancer with the target group. So how do we do it? So I'm opening a new tab. So this is for this tab is for EC2 instances. And for the load balancer, in the left navigation, if you scroll down, you have load balancers. Okay, now go to load balancer and create a load balancer. So we have types of load balancers: application load balancer, network load balancer, gateway load balancer, and also the classic load balancer. So the classic load balancer is a previous generation one, as it says. It's an older one. It is the first load balancer of AWS, basically. Okay, so it works in a different way, basically. Because it is a previous generation one, it is not recommended. AWS doesn't recommend to use previous generation ones. So there was an instance where AWS thought of removing it, but maybe the customers are still using it, so it hasn't removed the classic one. Yeah. Next, we have a gateway load balancer. This is the latest load balancer. This gateway load balancer basically evaluates the requests which are coming to the load balancer before it sends to the target. So it is used for more security, and this explicitly supports a protocol called Geneva protocol. Yeah, and it is used to manage a third-party virtual appliances. This has a specific requirement. Now coming to the application network load balancer, application load balancer, as the name suggests, it supports HTTP and HTTPS protocols. If you need to access an application using a browser, HTTP or HTTPS, go for application load balancer. Otherwise, you can go for network load balancer because network load balancer supports many other protocols, all TCPs, UDPs, and TLS. Okay, not only that, the network load balancer is designed for speed, where speed matters. It creates an IP address in each and every availability zone to improve the speed. Okay, but the application load balancer is used for content-based routing, like the applications. Like if you want to access the application using two different protocols, which are HTTP and HTTPS, then you can go for application load balancer. Now, in our scenario, We want to access the load balancer from the browser, from internet, right? Now, which load balancer we can use? Application, obviously, if you're accessing from browser, right? Hey, folks, please answer. Yeah, don't be sitting dumb, okay? How do I know if you're listening or not? So just give a tag, mark it as internet facing. We'll go for IPv4. Stick with default VPC. And I'm enabling all availability zones for the for the default VPC. Okay. Now coming to the security group. So the load balancer security group should be able to receive the request from the browser so that it can distribute traffic to the targets. So the load balancer security group must have a browser protocols open, isn't it? What is the browser protocol? HTTP. Okay. So what we will do, we'll create a new security group. I would say load balancer security group as a name and description. And I will add HTTP protocol. Keep it as anywhere. Create it. Now go back to close this. Go back to the load balancer. Do a refresh. Remove the default one and select the load balancer security group which we just created. Now coming to the listeners and routing. So application load balancer support HTTP or HTTPS protocols. We'll go for HTTP only because we don't have this SL or the TLS certificate. Port 80 and forward it to the target group. So now we have given all the options for load balancer. Now when it comes to target group, do we have a target group? No, we don't have. Now let's go and create one. So first is the target type. The instances, we'll go for instances because our targets are in instances. Give a name, target group as a name. HTTP protocol, IPv4, default VPC. I'll stick with the same version. Now coming to the health check, I will give the path. You remember? I said there is a path which we need to give to the load balancer. So we are giving in the target group step. Okay. And coming to the advanced health checks. So when load balancer is checking the health of the EC2 instances, based on the threshold, it will mark an instance healthy or unhealthy. Okay. Healthy, unhealthy. So let's understand this. So I have a load balancer, have an EC2 instance. Okay. Now load balancer will check the health of the instance, expects a response. If it is responding consecutively 5 times, because we have given as 5, consecutively 5 times if it is responding, the load balancer will mark this instance as healthy. Now after the load balancer making this instance healthy, it will not just keep quiet, it will still check. It will keep on checking. It will keep on checking. For instance, the EC2 instance hasn't responded once, twice. The same instance is marked as unhealthy by load balancer. Even after making as unhealthy, the load balancer will not stop sending traffic. It will still send. It will still send. It will still send. Now again, if EC2 instance start responding consecutively for 5 times, the same instance is marked as healthy again. So the load balancer will be keep on checking the health of it to make it healthy or unhealthy. And we can define the threshold, how frequently you want. So for both the cases, you can keep 2 to 10. If load balancer didn't get response for twice or for 10 times, if you keep 10, then only load balancer will make this instance unhealthy. Otherwise, it's healthy. We also have timeout. Timeout is, we have a load balancer. We have instance again. Load balancer will make a request, expects a response within 5 seconds. Timeout is the time the load balancer gives to the EC2 instance to respond. Okay, that is timeout. Now interval is, let's assume load balancer has sent a request expected within 5 seconds and EC2 instance responded, fortunately. Now to make a second request, what is the interval? 30 seconds here. These are the default values. So for each and every request, you can define, you can go from 5 seconds to 300 seconds. Even for timeout, you can give from 2 to 120 seconds. So based on the requirement, you can just control these options. Okay. Now, if I have a healthy threshold as 5 and then interval as 30, it will take around 150 seconds to make my instance healthy. It's too much for me. I'll go with 2 and I'll keep this as 6. Now, within 12 seconds, my instance will be healthy if it is, or unhealthy if it is not. Sorry. Okay. A success code, I'll keep it as 200, the default one. Tags are optional. Now here I'm registering the target. So basically I'm adding an instance as a target in the target group. So what to do, you have to select and then say include as pending below and then create a target group. Now that we created a target group, now close this, do a refresh and select the target group. Okay. I'm not adding any add-on services. It will charge us and it's not even required. Load balancer tags are optional. Now summary, it will show you what are all the options you have selected and then you can create a load balancer. Now that the load balancer is being created, and this is the DNS name which I'm talking about. Okay. So we just have to give some time for the load balancer to create successfully. Now, as of now, under the load balancer, in the target group, you have only one instance. So how do you see? You just need to go to the target group, click on the target group and go to targets. You see, there is an instance, there's a tag which is given to it and the health status is initial. So we have to wait for the instance, a load balancer to create completely and to check the health of the instance. So it will take a while to make an instance healthy. Now, once the instance healthy, see, once this instance is healthy, then only we can access the EC2 instance through the load balancer, isn't it? From internet. Yeah. So any questions so far? You're following me?
Yes.
Let's wait. Yeah, now that instance is healthy. Okay, now you can simply take the load balancer, DNS name, and keep it in the browser. Now the load balancer should direct to that particular EC2 instance, which is in the target group. So good that it is working fine. Okay, till here. Yeah. 1 second, charge. Yeah. Now what we will do, let's go forward. Now let's create a launch template and create an auto scaling group from the template, defining the policies and capacities. Yeah. So this is for the instances, this is for the load balancer and target group. And the third tab is for the launch template and auto scaling group. So in the left navigation, under the instances, you have launch templates. So from the launch templates, create a launch template. Okay, give a name. Yeah. Hopefully hyphen supports, otherwise we will change it. Okay, now I'll give the same description. See, this launch template is very much same as like while you are launching an instance, you select the options, right? So the same way in the launch template, you select the options. Okay, now what options to choose? What are all the options you have chosen for the manual instance? We choose for the template also, because it has to add similar kind of instances, right? So first thing is AMI. I'll go to quick start AMIs. Go for Amazon Linux 1. That too Amazon Linux 2. Amazon Linux 2. Frit eligible. Instance type, I'll go for T2 micro. Frit eligible again. So I will not include in the launch template because there is no option where you can choose without a key pair. So let's not include in the launch template. Even the submit will take automatically. Okay. But for the security group, create a security group, name it launch template security group, same as description. Okay. Now, what the manual instance of security group is having? HTTP protocol, right? That is the reason we accessed using public IP address, right? So add a HTTP protocol. Source as anywhere. Go with the default VPC. Okay. Stick with the root volume. Now coming to the advanced details, you need to do the same thing which you have done for the manual instance. Very important. Okay. If you miss this, again, it will create a lot of queues. So you have to enable the metadata. It is by default enabled. The metadata version is V1 and V2. Okay. So you can just say, simply enable it. In the user data, you can just copy paste, except that here you are keeping manual instance, right? I'll just name it as auto scaling instance. That's it. Just a name. Auto scaling instance. And I'll create a template. Hopefully it is created successfully. It will create. Yeah. Now that we have the template. Okay. So from the template, you can create an auto scaling group. Nowadays, if I do this way, it is throwing an error. Let's see what it will happen today. Hopefully AWS has fixed this. Cool. Okay. I mean, as I said, now it is working. So give a name, auto scaling group. You have a lot of steps. We need to just enable a few options. Launch template is already selected. This is the name which we have given. The security group, the instance type. We haven't given key pair. Sticking with the root volume. Okay. I'm not changing anything. The first step is just giving a tag. That's it. Now here, for the VPC, we will choose all the availability zones like we did for the load balancer. So that the instance can be launched in any availability zone. The auto scaling group will add an instance in any availability zone. We're giving full flexibility. Okay. Now we are adding the target group under the auto scaling group. So we have to add this target group under the auto scaling group, right? So that has to be integrated. So attach to an existing load balancer and select the target group. Health check grace period, I'll keep it as 10 just to save some time. And I'm not enabling any more options. I'm just attaching a load balancer in the third step. And I'm just reducing the grace period. No CloudWatch metrics enabled. It will charge us, folks. Now coming to the group size. Decide I'll go with 2. The number of instances I want to start with. Min as 2. Max as 5. Okay. Now I can define a policy also. I can give a name to the policy. Average CPU utilization is greater than or equal to 80. As I said, it can be completely flexible. And it is not always a CPU utilization. You can also go for network in and out. Load balancer request count per target also can be defined. Maybe if the load balancer sends a request to a target 1,000 times, then I want to add another instance. So you can define that way also. But in our scenario, go with the thing which we discussed. So CPU utilization. Now you can disable the scale in, only scale out. So scale out is adding an instances. Scale in means removing the instances. Now, if you want to disable the removing the instances, you can disable it. You can do the same here also. It's exactly the same. Enable scale in protection. Okay. So we have 2 options defining the same meaning. I'm not enabling either of them. Okay. So we are not going for this, is a new option, not required, not relevant. And if you want to get notified for every launch, for every terminate, fail to launch, fail to terminate, you can create an SNS topic and then you can enable whatever the event types you wanted. I think we have enough for now. So I'm just removing it, but if you're interested, you can add and try. And coming to the tags, last but one step. So I'm just adding a tag, naming it as auto scaling instance. Review, so you can see all the options you have chosen. And you can simply create an auto scaling group. Now that we created a launch template, and from the template, we created an auto scaling group, defining the policies and capacities. Now, to maintain the minimum number of instances, auto scaling group must launch 2 EC2 instances in the target group. Okay. So first, what we will do, we will go to the EC2 instances and do a refresh. You see, there are 2 instances which are added. They're initializing, just created. These are the new instances which are just initializing. If I see the time, see it's 10:38 just now. As soon as I clicked on auto scaling group immediately added 2 instances. It was created, the manual instance is created at 10:16. And these are just now created. Okay, first thing. But these instances must be in the target group. Now let's go and check in the target group. So go to target group. Here I'm seeing only 1, but do a refresh, local refresh. Now I'm seeing 3, and these 2 are also healthy, superb. Usually it take a while, but it was very fast. Now these instances are healthy now. Now if I access this load balancer from the browser, manual instance, auto scaling group instance with IP address ending with 21, auto scaling group instance ending with .80, manual instance. Auto scaling group 21, auto scaling group 80, manual instance. So I think now it should make sense why I have kept some statement here instead of a default page. If it is a default page, if you're refreshing, you may not know whether it is going to different instance or not. Now you can clearly see because it is actually changing the IP address. Make sense? Any questions, please? You're getting me?
Yeah.
Folks, just give me someone is at the door. Sorry, 1 minute, please. Someone is at the door. I'll be back. Yeah, questions, please. Sorry, I missed it.
Actually we are able to get, I'm able to get it, but it needs some hands-on, Anupama. I think I need some.
Definitely, the rest of the time is for you only, folks. You can take your time completely to complete this hands-on. I'm happy to help you if in case you're stuck. Okay. As I said yesterday, the concept would be simple only, but there will be a lot of steps which you have to make it come slowly and consciously. You need to integrate them. If any one of the step fails, you will face the issue. Okay. So what you need to do is to make it successful. Check at each and every step. For example, launch an instance and make sure you check using the public IP address. Without checking, if you go to load balancer and then you add the instance, and if the instance itself is not working, then you have to do from the very scratch. And again, second step is creating a load balancer target group and adding that instance. Now, once the second step is done, check the load balancer from the browser to access this instance. Then the second step is successful. Then go to the third step, launch template and creating an auto scaling group from there. Defining policies and capacities, and auto scaling group will add 2 instances and check the last step, like the fourth step, accessing the instances from the browser. Okay, so make sure each step is validated before you go to the next step. Folks, I'm repeating again because most of the learners, we just do all the steps and then they say that the instance itself is not working, even though I would ask to validate each and every step. So please don't do that mistake. So if you could validate each and every step, and if you're stuck and if you're not able to get it, you can just call me at that time. It is easy to fix. Otherwise, it will be difficult to even troubleshoot. It take a while. Make sense? Yes. Understood? Hello?
Yes.
Yeah, okay. So let's go for a break first. And then you can continue doing it. Unfortunately, if you complete it soon, please complete all the remaining ones because it's the last day. It would be great if you could complete everything today, and then, yeah, I can, then you can start preparing for the certification also. Yeah.
Anupama, one small favor actually. Are we uploading these recordings today itself, or it's taking some time for them to do it? Generally, not sure it's coming
Generally, it
this
doesn't take
evening.
much time, ma. Generally, it will be done by evening only.
Okay, it would be great for that. Okay.
Yeah. So if you check the recordings, which was shared so far, you can see when they have uploaded.
Yeah, so far they're not doing the same day actually.
We need to chase them. Okay. We just need to chase them to get it done on time.
Okay, I'll do that.
Happy break, folks. Hi, is everyone back? Folks, am I audible?
Yes, yes.
Okay. So let me create the breakout room. Please complete the project too. And also if you have any pending ones, okay. And if you are, once you are done, please come back to the main session. Just leave a message and you're good to go. Okay. And please call for help if you have any questions. And follow the instructions which are in the assignments folder. Yeah. And I will share this screenshot, whiteboard screenshot in the WhatsApp. Probably just give me some time. I'll open it and I'll give. Okay.
Okay.
Yeah, perfect. So please do join your rooms.
Anupma, please let me join the room.
Sure, Akshat.
Thank you.
Sunita, can you please join to your room?
Sorry, come again, please.
No, not to you, Akshat. I'm talking to Sunita.
Oh.
Sunita, you there?
Anupama, can you do a small favor? Can you add me to the break room where Anjali is there?
Sure, sure.
Thank you.
Done. Have you guys completed?
Yeah, Nupama.
Everyone, clean up.
Yes, done.
Yes, ma'am. Yes, ma'am.
So first of all, you need to delete the auto scaling group. Just cross check. Okay. So auto scaling group is created from the template. So delete the template also now. Please go on mute. Now delete the load balancer. With load balancer, we create a target group. So delete the target group also. Now go to instances. So delete only the manual instance because the beauty is auto scaling group will terminate its instances. So it's still deleting, no? So see, it is shutting down. So auto scaling group takes a while to delete it. It's still deleting. So it will terminate its instances, not to worry. So I'm just terminating my instance, which I created manually. So you shouldn't be terminating the instances first because if you terminate the instances, auto scaling group immediately to maintain the minimum number of instances, it adds 2 more. So when explicitly when it comes to auto scaling group, you have to start from the last. You have to start deleting the auto scaling group first, followed by the other components. And if you observe, the instances, the load balancer, auto scaling group are all part of EC2 only. Okay. So it's always a best practice to cross check whether if everything is deleted or not. So launch template is deleted, load balancers are deleted, target group is deleted, and instance is still shutting down. Okay, now it is terminated as well. Okay. Now auto scaling group is also deleted. Okay. So now if I go to dashboard, I should not be seeing any volumes, any snapshots. Security groups and key pairs are fine. Instances running should be 0. And even if it is showing as 3, if they are terminated, it's absolutely fine. Okay. So congratulations on completing this course, folks. Now you can go for this certification part. So this training certification is AWS Solutions Architect. Associate one. Okay. So if you attempt the certification, it is globally recognized one, and this is how a badge look like. This you can update in your resume or in LinkedIn to increase the credibility for your profile. Okay. Now, in the drive link, which I have shared it to you, there you might be seeing exam resources as a document. Okay. There I have given some necessary links where you can go to. They are third-party ones. It's up to you. Okay. Those are just suggestions. Now, it's highly recommended to explore this page. I'll keep it in the chat. Okay. Now, who should be taking the exam? What you will be learning? Okay. Now, the exam would be for 130 minutes, cost $150. If your organization is already a partner of AWS, if you're already working in AWS projects, most likely you will be getting a voucher for free where you can attempt it. Okay. So either paying $150 or voucher, it is like a pass or fail exam. You have option, you can attempt only once. Okay. Now, if you fail, you may need to again pay $150 to re-attempt the exam. If you pass, you would be getting a badge. You would be getting a badge. With that, you would also get a 50% off on the next certification. Okay, so for the first certification of AWS, you may need to pay completely from your pocket, like the complete amount. But if you pass, every time you pass a certification, you will be getting 50% off on the next certification, whatever the certification it could be. Okay, and you also have access to AWS commodities, like you can get a AWS logo having a bottle, okay, on shirts, on t-shirts, okay. So you would have access to few of it where you can just buy them. But the ones which are relevant would be like 50% off on your next certification. So where you will be having 65 questions, either multiple choice or multiple response. So multiple choice is basically where you will be having 4 options. You may need to select the correct one. Multiple response means you will have 5 options, 5 or more options. You may need to select 2 or more correct answers. You will not have any fill in the blanks. There will be no labs which will be there in the exam explicitly for this solutions acted one. Okay. But doing the labs would helpful to you when you are answering the questions. So the questions would be scenario based. It is highly recommended to go for the practice test. Like, there might be some sort of practice test in third party websites, or in even AWS, you'll have it, some sample questions. So you would know how a question look like. So it is highly, and it is what I would say is it's very much mandate to go for practices before you actually attempt the exam. So because in this course we have learned the concepts in AWS, how a different services work, of course very much relevant to the certification. Okay. But in the practice test, you would know how a question would be framed, so that your brain would be habituated to type that such kind of questions. So the advantage is that when you are attempting the exam, if you haven't done the practice test, it may take time. It is not that you can't answer it. You can answer it, but it will take time to understand the question and answer it. So you may run out of time to answer these questions. That is the reason it is recommended, highly recommended, to go through the practices before you attempt the exam. Okay, folks, this is a right time where you can start attempting or preparing for the exam. Like you can prepare for 2 to 3 weeks. Ideally, this is how I suggest. Okay, so before you forget everything, just prepare for the certification and complete it and get it and add into your bucket. Okay, so cloud is everywhere, as you would know. That is the reason we are learning cloud here. So having a cloud skill is a good thing when you are explicitly migrating to cloud, or when you are adopting the cloud, or you're looking for a job in cloud, etc. Yeah. And if you need to prepare for the exam explicitly, so there are few exam guide you may need to understand, some sample questions, some practice. Okay, so this is for free. I think you'll have some 40 questions also. And digital training is something which we have already covered, but if you would like to go through it again, please, it's up to you. Okay. And exam readiness. So these pages are updated very recently with lot of information from AWS. Please explore it. Okay, you can also explore, these are subscription based, you may need to pay, you can just ignore this. And wherever you're seeing it as free, you can just go through it. Okay, AWS white papers which are relevant one, FAQs, these would be helpful when you are preparing for the exam. So ideally, my training, the labs which you're doing, and practice test is enough. Okay, but it's not about just doing the certification, it's all about learning it. Okay, so basically that is a difference between my training and other trainings which I see in the market. So you need to not just by heart something and then attempt the exam. You just have to learn it so that you will be ready for the real time experience, or jobs also. Okay, so let me keep this in the chat. You will also have access to one second, folks. Can I take photo? Prakash, I'm not sure. Yeah, you can take it, not a problem.
Okay, ma'am. Thank you.
Yeah, yeah. Thanks. Okay, good to see you, folks. I'm sorry. This will be there every month, so usually I will not be there in the photos. So that's about the certification. So what I suggest is, please prepare for the certification, complete it. Yeah. If you have any questions, you can. I'm happy to assist. You have my WhatsApp number now. Yeah. So I've been posting in WhatsApp group also. So if anything is there, you just message me personally. Even you can message me in the group also, but the thing is like after the batch is completed, it is very hard for me to check the group because I have something like 20 plus groups. Every month there will be a a WhatsApp group created. So you may get response little sooner if you just personally message me. And please don't call me straight away because I might be in other trainings also. You can just message me if a call required. Definitely we will discuss. Okay. I think it's that's it. All the best, folks. Any questions for me?
No, Anupama. I'll directly ask you if I have.
Okay.
Yep.
Thank you, Anupama, for your wonderful session.
And may I know what about our rest of the classes? Are we going to, how are you going to coordinate with that? Or the
Yes.
support will be helping us of Star as
Which rest of the classes?
of DevOps also, no?
Okay, I'm not a part of it. Just check with. I'm not the right person.
Okay.
Check with the admin team. Okay.
Okay.
Yeah. Okay. So if you don't have any questions, folks, I think you're good to leave. All the best.
Thanks. Thanks, Anupama.
Yep. Bye bye.
Thanks, Anupama. Thank you.
Thank you so much for the feedback. Yep.
Thank you.
Thank you.
Thank you, ma'am.